Hello, friends. So I've given this presentation live at the Bush Convention Center in Midland, Texas, and it's about navigating land, my perspective on it, an engineer's perspective, and I like to call myself as an oil woman, so it's an oil woman's perspective. This talk is about how land was really integral in my career as a reservoir engineer and how I realized that it was a skill set that made me a better reservoir engineer. As an outline of the presentation, I'll describe my experiences, how landmen and engineers can help each other, example interactions, and what are some educational resources that engineers could use and as landmen can use to speak each other's language. So let's talk about my experiences first. I want to describe the scopes of reservoir engineering, and as I progress in each scope, when I talk about this, you'll notice that the closer and closer you get to land, and land becomes a little bit more relevant. So reservoir simulation engineers focus on developing a model for reservoirs and coming up with a recovery, development styles, and what is the theoretical as part of the application for development. Then you have technical analysis, such as using actual production rates and pressure data to look at some of the actual data and then come up with predictions on a well's recoverability. Then you have decline curve analysis, which is the most common method used for well predictions for reservoir engineers. Then you have business development, which is looking at competitor performance and then looking at the economics. And then finally, it's running economics, running the economic software, taking into account your forecasts and looking at how much is the reservoir going to produce and is that development economic. The point I want to make with all this in terms of the many hats reservoir engineers wear, this is not an exhaustive list, but understanding land may not be the main focus for all scopes of reservoir engineering. But without land, we can't do our reservoir engineering work. If the unit is not ready, if that unit is not available to drill, then we can't do our work. Here's what I thought my first reservoir engineering job was going to be. I thought I would be focusing on the technical things, and I will be identifying where to drill, how many wells to drill, and prove that the wells that I drilled are economic. So I thought that was going to be my first job, and that was going to be the entire scope of my job. When I interviewed for my first job at Endeavor, reservoir engineering job at Endeavor, my boss at the time told me that I had the technical skills down, like I am a good candidate. The one thing that I was missing is land skills. At the time, I didn't understand what that meant. And I thought I understood land, or I could understood land, but I didn't know the complexity of it. This is what I thought it took to be a successful reservoir engineer. I thought if I can get my math and science down, if I could get my decline curve analysis down, if I get my predictions down, if I can be a reliable, repeatable type of engineer, then I should be good. However, what it really took was the additional skills that are required in project management. For example, building relationships with cross-functional teams, and then working with the landmen, most of all, for my development and for my growth. This is how I felt when I was in a land staff meeting at Endeavor, where I felt the landman was speaking a different language from myself, and the landman was talking about the development in a different way than myself. The amount of tracks that are in a unit rather than the whole unit or the whole drill spacing unit itself. And whenever I talked to the landman when it came to forecast, well spacing, and predictions and technical things, it all went through the landman's head. However, over time, I learned how to communicate to a landman, and over time, my landman knew what I was thinking about as far as predictions and valuations go. So it started off as speaking two different languages, and we were talking past each other, but that communication ended up getting better and better the more I interacted with my landman. So how did I learn land as an engineer? Honestly, it was the hard way because I didn't take any oil and gas law in my university education. And I didn't have that available for me in my university education, my bachelor's or my master's, and I didn't pursue that either. the time. So the way that I learned land was the hard way. I need to know who my landman is. I need to talk to my landman on a frequent basis, not the night before a development review. Ask questions, because there are a lot of abbreviations in land like CDC, JOA, JDA. I have to learn the land lingo, learn what landmen value, and then speak to that. I learned how to build relationships with my landmen. And then I also went to land conferences such as NAPE. It's a huge land conference. I remember going to NAPE in February 2018 and speaking to 60 companies when I was looking for opportunities. But that time I learned how landmen talked and what landmen were looking for and what they presented. And then when in doubt, you need to consult your landman. So how can landmen and engineers help each other? That's a question that I think a lot of people need to answer. So for the first one, and this is a primary one, you work with landmen to construct your development plans. That's how engineers can help landmen. Now, a lot of this information is what your landman should be giving to you, but the reason why I say your engineer should be giving to your landman is shows the proactivity that your engineer has with your landman. So, examples of information to give to your landman and the other way around is formations that are interested in drilling, what tracks the laterals are crossing, is it a different surface owner, a different landowner, mineral owner, the valuation of full development, the valuation of trades, is that going to be accretive to the operator? Will this align with operator strategy? It's on lease, off lease, surface use agreements. Is this in alignment with any clauses with the mineral land agreement? Is this in alignment with the surface owner? The regulatory environment, are we working with the BLM, the GLO? Any possible commingling? Is this production going to be allocated? Is it pooled? If the development of interest has a recent title? And think about anything else that you have in mind of things that engineers can give to your landman and the other way around. Now, how can landmen help engineers? Notify the engineer if you're in title yet. Are the formations of interest available to drill? Is there a language in the leasing agreements that the engineer needs to know that might affect development, such as bank days, or in the CDC, how many days we have left to drill the next well, PU clauses, depth restrictions and agreement. I've been in situations where one operator affected had shallow rights and the other operator had deeper rights. Trade deals. Any upcoming conversations with operators, surface landowners? Is there a particular tree to avoid when developing land? And then third-party takeaway developments. The next way that engineers can help landmen is help your landmen develop trade deals. So here are some example interactions when it comes to those trade deals. The first interaction is this problem. Operator X under the JOA is interested in a trade on Block 5, Section 5 Northeast Quarter Tract. What is the valuation per acre? This is the working in NRI. So the reservoir engineer does the evaluation with the number of formations, number of wells to drill for the entire section, economics on all development for a 2-mile section, divide the NPV by 1280 acres for a 2-mile development, multiply the number of acres the tract covers, or the NMA, the net mineral acres, and then you give the total acre evaluation and the dollar per acre to the landman. Here's another example interaction. Energy Company Y is interested in carrying 30% to the tanks of development of Block 5, Section 5 Northeast Quarter. What offer should we give them if we take it? Should we take the offer? Can we negotiate a higher carry to the tanks? So the reservoir engineer does the evaluation, number of formations, number of wells to drill per section, economics on all development, runs a carry case, collaborates with the landman by notifying the best deal of the company and also what aligns with both operators. Could we do a term assignment? And then the next interaction, our development of interest was an old water flood. What formations can we drill and what is the history of these vertical injections? So the landman can do some digging, communicate with the RRC and injector history if not found in public record, review historical UICs, which is a Railroad Commission document for injector wells, review historical title and check how to name future wells, and then notify the reservoir engineer of injector history and title status. So here are some lessons I've learned when working with land teams. The first one is collaboration is key. Collaborating with your landmen is very crucial, and with cross-functional teams. Land teams love to communicate with technical teams who have an appreciation of the landscape. Pun intended. Then do not interact with your landman for the first time the night before a development review. Questions are appreciated. There's no such thing as a stupid question. I did learn how complicated land is, with lease language, going through title, how long it takes, and then focus on the surface of the land and subsurface land. So you have to not only communicate with your mineral landowner, but your surface landowner as well. Next, and we'll talk about our education resources. So how engineers can get educated in land. There's plenty of resources, and this is just to name a few, not an exhaustive list. OU and Masters in Energy Law is a program. Texas Tech University's continuing education program in oil and gas law. TAMU has an MLS in energy, oil and gas, and law. You can always read a book and then talk to your landman. How your landman can get educated in engineering. University of Texas has a continuing education program where you can take PTEX courses, or oil and gas courses, technical courses such as drilling engineering, production engineering, reservoir engineering. TCU and OU have energy MBA programs. So that is an MBA that is specified towards energy, and that is requiring to use some of your engineering skills to come up with business solutions. So that will help you tap into the math and science for some of those business problems. And then be curious when talking to your reservoir engineer. Ask a lot of questions. Like, how many wells are we going to drill in this section? Are there specific tracks that we have to be worried about that I need to get ahead of? That's everything that I wanted to share with you all as far as the presentation goes. Obviously, this is a shortened version of the presentation. I would have a lot more description if I were speaking to this live, but I believe that this is going to be useful content for those who are going to start off their careers as reservoir engineers, and they'll be required to wear many hats, and land is not something that you should ignore.